Okay, hello. I wanted to make a video because I got inspired. And when I get inspired, I tend to get ideas. And when I get ideas, I tend to kind of act on them. So I wanted to just share it. It's nothing finished, but I wanted to explain like the process behind it, where it's at, and where it might end up. And it's related to state management because state management is such an unsolved thing. Every time there's a new project, there's a new state management solution, and they emphasize different parts of managing state. And it's like it's an unsolved problem, and it's not about like finding one solution that fits every project, but it's just keep iterating and try to figure out better ways to manage state. And this time I got really inspired by this presentation by Brett Victor. I didn't know about this guy, and he's like a thought leader on how to work like creatively with computers, because doing programming is actually a creative process because you have to solve problems. We are typically building UIs, and the process of us doing this is very disrupted. Like we save some code, we usually have to refresh the browser, and it's such a massive amount of complexity that's very, very hard to infer reading code. So he talks a lot about this stuff, and he also has this other presentation on the future of programming, where he's kind of going 40 years back in time, kind of like presenting what programming should look like now, and how it doesn't look like what you'd expect 40 years ago. And specifically, he points out the actor model, which is a pattern. And the reason he points it out is because as processors get multiple cores, they can run code in parallel. And having a programming model that fits with running things in parallel makes sense. And as he like makes fun of, we haven't really embraced this model, though you do see it in things like Elixir, for example. But again, they take advantage of running on multiple cores and stuff. And in JavaScript, this doesn't make any sense at all because you only have one thread to work on. So the actor model as like a solution to managing multiple threads and stuff doesn't make sense in that sense. But it's like an interesting concept in general, this decoupling of logic, because from one side you want to decouple as much as possible because it makes it easier to introduce new stuff, replacing stuff, and so on. But this high degree of decoupling makes it so much harder for your brain to understand how does everything fit together. So how would you like find a good way to handle both of them? So the actor model is basically you have these actors that is like a piece of logic where they pass messages to each other. Yes. By the way, I wrote all this stuff down as I was thinking about it, and started writing up an API where I kind of thought about this stuff. So I'm going to put this in the video. But so I just wanted to explore this, like how would like a actor model programming pattern look like in taking into account all the stuff I have experienced personally, trying to manage state. And as I mentioned, an actor is basically an entity that can receive a message, it can send a message, and it can hold internal state. And the question is, how do you actually implement this? Because personally, I have had really bad experience, if we look on the picture here again, having like entities that just passes events to each other. Like you have no idea what order things is happening, if the event you send out will be handled correctly, or maybe you send an event that shouldn't be handled, or you don't receive an event that you expected to be received. And it's really difficult to manage the internal state of everything, to deal with the different messages and stuff. It's super, super complicated. So I started thinking about how can we still do this, but improve it. So one concept that has recently got my attention is like state machines and state charts. But it's been very overwhelming. I haven't embraced it, even though, for example, Overmind has state charts, but it also has like state machines, because that's where I see like the core value of managing state better, is that you have an entity that has a certain number of states, and it can only be in one state at a time. And based on the state that is active, that is what dictates what can happen to that entity. Yeah, so like an actor is, the way I would define an actor is to define it as a state machine. A state machine that is able to send and receive messages. So basically, oh, it's my mother. Let's see. I'll just do not disturb. Sorry about that. Anyways, so instead of just defining some state on this actor and start firing off messages, we define it as a state machine. So the current state of this machine is loading, and then it can manage some events, like it can receive some events. But sorry about that. But it depends on what state the actor is in, what events it should handle. So it starts in the loading state, and then it has like loading and loaded. And it can also define some internal state, which I call data. And then you can define, okay, what kind of events can this actor respond to? And in what state do they respond to these events? So in this example, we have like in the loading state, it will react to the event update data. And then it has, that's defined by a function that returns a function. So the first argument here is the current data. And then we receive the new data on the event. And then we actually return an array here. And if we scroll down a little bit further, we see that, as I said, first we have the current data, we get the new data. This should be new data. And then we return an array either with the new data or the new data and the new state. And this is what is called a tuple. And this is not something that's very often used in JavaScript. It doesn't have a concrete concept of it. But for example, in Elm, you have a strong concept of a tuple related to state management. So whenever you change state in Elm, it returns a tuple of the new state and optionally a command. And a command if it's a tuple. So what happens here is that if you were to define this update data event, where it returns the new data and it returns a new state, it will actually transition into the loaded state. So as we can see here, that we have this app with dispatch update data bar, and then it changes its state to loaded, and then the data becomes bar. If we were going to look at this in a more like real world example, we could have like a login actor, which starts in an unauthenticated state. And then it has unauthenticated, authenticating, and authenticated. And during the unauthenticated state, you have the ability to update the username, the password, and you can submit. Now, what you can do here to kind of guard these events in terms of updating the state and transitioning to a new state, you can just write plain logic in them. So in this case, if the username length is more than 3, then we actually update the internal state. And if it's not more than 3, we will return the new state with also a validation error. And it's the same for the password. And then when we submit, we make sure that the length of the username and the password is like more than a certain length. And only then we actually transition into the new state. If not, we just return the current data. So this just ensures that when whatever outside triggers these events, the actor decides how to act upon them. And if there's a successful submit, it will move into authenticating. And if you were to trigger these events again, when this actor is in authenticating state, it wouldn't be triggered at all, because it's not defined that it should handle these events when the actor is in an authenticating state. Yes, but the question is, everything in an actor here is completely synchronous. It's not doing any side effects. And how would you compose all of this together? This is just a login thing, but the login is probably part of an app, and then you might have many different things that is part of your application. So this is where it starts to get interesting. So in this case, we're still looking at the login actor, and it moves into an authenticating state when you submit and everything's okay. And then in the authenticating state, it expects to get a login success event or a login error event. And these again moves the actor into a new state. But the question is who triggers these events? And that's the decoupling thing with this, is that the actor doesn't care. The actor only receives these events, and then and given the correct state, it will change its internal data, as it's called here. So doing side effects like asynchronous stuff, talking to the server and so on, that's something that's done outside of the actors. As we can see in this example, we say that whenever the login transitions into authenticating, it will run this function. And this function does a post to a login thing, and it passes the current username and password from the actor. And if it's a success, it dispatches a login success, and if it's an error, it dispatches the login error. So this is how you're able to communicate with an actor, is that you can listen to a specific state, and when the actor transitions into that state, you can run some piece of logic and then dispatch something back. Now, the beauty of this is that if the actor were to, for some reason, go away from its authenticating state while you're still trying to post the login, it wouldn't be able, it would still trigger login success and login error, but the actor wouldn't deal with them because it's in the wrong state. And this is exactly how state machines work. They just ensure that that you control what events should be handled by transitioning the state of the state machine, or the actor in this case. And now the question is how would you deal with parallel behavior? So for example, up here, when you move into authenticating, you can't get out of that state until you receive a new event. But that's not always what you want. So for example, if you had a list of to-dos. So initially it loads the to-dos. And sorry if you're hearing some crying in the background. It's our 3-year-old. And yes, so it's loaded. And then whenever we allow adding a new to-do. But in this case, whenever we add a new to-do, we transition into the to-do submitted state. And we're not allowing you to add the new to-do anymore. We only allow it to indicate that it's saved or there's an error, just like the example above. And this is not really ideal. We want to be able to add multiple to-dos at the same time. So what we can do here instead is that we can we can create an immediate transition. So as we can see here, we have to do added, to do saved, and to do error when we have loaded everything. So we don't only have the added, we also have the saved and the error. And whenever we try to add a new to-do, the actor will transition into to-do submitted, but then it will transition right back to loaded. And that means that the to-do submitted event will be emitted out, but then it's back in the loaded state, which means that it can deal with any saved and any error events. And this logic is very brute forcey, but the point is that this is how you would handle these kinds of scenarios. And then, as I mentioned, like, you want to extend all of this. So in this case, we're just running some side effects whenever we transition into a new state. But you could also attach an actor to an actor. So for example, in this case, we have an app actor which loads some initial data from somewhere. It doesn't care where it gets it from, but it gets it from somewhere. And then it transitions into the loaded state. And then we have a login actor. And we don't want this login actor to be running unless the app is loaded. That is when you actually want to start a login flow. So we do that. We say that app on loaded, fire up this login actor. And it will actually start and stop automatically. So when it transitions into loaded, it starts the login actor. And when it transitions out of loaded, it will stop the login actor. Yes. Yes, and that's also the case for these side effects here. If you return a function from them, that function will be run whenever the state you listen to exits. So it's kind of like a React hook, basically. And now the question becomes like, the code is still very decoupled. It's difficult reading the code, how everything works. But this is where we need tools. And this is what I've learned from building Cerebral and Overmind, is just how powerful these development tools are to build the mental image for you. So you don't have to spend time looking through all of your code to figure out how stuff works. And for this kind of pattern, it becomes even more important. So you could have like a development tool where it shows the different actors as like nodes or something. It shows all the states they have, and it could indicate like what kind of events are being emitted, what payload is being passed, and stuff like that. And of course, you could have like a slider at the top where you could then just move back and forth in time, and you will see how these actors communicate with each other. Very simple stuff. And I actually found this library called React Flowchart, which is super interesting because it has this node tree. So you can imagine that all these boxes here are actors, and then you would have these lines in between where you see where one actor or one side effect listens to a specific state transition and stuff. Super interesting. And even you could turn this around, so you could start actually building actors in a UI, just like they show in the demo here. You wouldn't necessarily be able to effectively build the code for what you're designing, but just as a design tool to figure out how to do something, it could be super powerful. And if you know XState, you're probably like, isn't this XState? And the thing about XState, and I was a bit surprised by this because I've heard David, the author of XState, talk about the actor model pattern at some occasions, but I didn't know that X8 actually has like an actor concept underneath. It's kind of hidden in the documentation, at least from my perspective, because X8 is very much focused on state charts, and state charts are powerful in the sense that you are declaratively describing a very complex flow. And declaratively is better in terms of building visual tools. It allows you to use the visual tools to create a declarative output. That's much more easy. That's much easier than actually outputting code. But why I'm not embracing state charts is because I don't see how you could actually create a state chart for a whole application. You would kind of like have these very complex declarative descriptions, which doesn't make you much smarter in understanding what is going on. And again, I don't see clearly the boundaries between a state chart and like an actor, and to me it feels confusing. So I wanted to like just take that tiny little concept of an actor, which is like a simple state machine, and then see where it can take us. So just an example, in X-state, you have this kind of definition, which is perfectly okay. This is quite of a simple thing. But with this library idea thing, it's more, you code it more. You just express it with code. And that's like a state chart tries to declaratively express code in many cases. And it's like this is like this condition. It's like an if. And sometimes I feel like it's just trying to express the code you're just trying to write. But I see where it's going. It's going towards being completely declarative so that you can visually build everything, and then you kind of attach your logic later. And it's going to be exciting to see where X8 goes with this, and see how far it can take it, because if you might get to a place where you don't even write the state chart. You build it visually, and then you rather have specific hooks for adding the logic of, for example, here is not max, is not min, for example. That's going to be fascinating, but we're certainly not there yet. Okay, I've been talking a lot. I also have a demo here, just to kind of like show you this in practice. So I have this tiny thing I built. Let's see, components. Okay, so I have a component here. Let's see if this is working. So what's interesting is when we define these actors with TypeScript, you define different states. So it has a loading state and a loaded state. When it's loading, it doesn't really have any data. But when it's loaded, it actually has a title. And then it has two different events, where it's the name of the event and what kind of payload it takes. And as we can see in the definition here, everything's actually typed and helps you out. Where on loading, if we receive a title updated, we return the new data, we say loaded, and then as you can see, when I have data here, it doesn't show you that there's anything there because it doesn't expect there to be anything. But when I hover here, it expects there to be a title because that's related to the state it's running in. Then I'm just acting on loaded. I'm doing a set timeout where I return a function which clears that timeout, and then we just dispatch something. It's just silly stuff. What's interesting though is that when I now check the state, I get the typing of the data. So it also here, when I write a component code, when I check the specific state, I get typed the specific data related to that state, which is a super powerful concept. And then like use actor here is a very simple thing. It just sets the data and sets the state whenever the actor updates. Okay, so what's kind of cool about this? If I reload, it just says loading and then it says yeah. But what's interesting is what I talked about, this visual tool. So if I drag this back to the start, we can see that, okay, the first thing here is that we added an actor. And then we added a subscription to that actor, which was unloaded. And then the actor started. Then there was a dispatch, title updated, and the payload was yeah. And then we can see that it was loaded, and we can also see that the data of the actor has updated to yeah. And then we can see that foo updated was called, and we even know that it's from this side effect, like because it's from an event. We know that the calling of foo updated is related to the unloaded side effect, and it passes the payload bar too, and then now the actor has a new piece of state. So you can imagine having this big node tree, which I showed you the library from, where you can, instead of sequentially see like stuff running, you rather have an overview of your application. And by using this slider, you will be able to identify what parts of the app is updating when. And you can do things like, okay, I'm interested in this actor. So you can click the actor and then you can use the same slider, but it's filtered on that actor. So you can only jump between stuff that has happened with that specific actor. You could even do things like, okay, click the state, and you will get a list of, okay, what has happened, how many times has this state been triggered? You could click the events and you could see how many times has this event been triggered with what payload. And you could click the event and then it would move the app back into the state of that specific event being triggered. So you can see, okay, what was the state of the rest of the app? Like it's, for me, this seems like such an insanely powerful tool. And as you can see, currently it doesn't update the actual app. It will be trivial to add that. But I don't think that's the power of it. It's not to work with UI, like figuring out how the UI should work. It's this ability to kind of like load up your app and then just have this slider where you kind of like, you just wave back and forth, like what's been happening inside my app, and you just see everything running. For me, that's super inspirational. Okay. So I've been talking a long time now. I hope this made sense. I haven't published the library. It's actually running. I wasn't supposed to implement anything, but I just can't help myself. So I have running code for this. It's very, very simplistic. It's just this tiny state machine thing with some event handling. And then there's like a dev tool component to this. Which basically just builds up a history of everything that's happened. And then that history can be translated into like a DevTool experience. And so what I want to do, what I hope to find time for, is to actually move this DevTool into this experience. I've been playing around with it, and it's actually not difficult at all. It just takes time. And I'm really excited about that, because what you will get then is this canvas where you can zoom in and out as the history progresses. We can even create a tiny delay between every entry in the history, so you kind of see every every part of the canvas kind of blinks and highlights as different things are being updated. And then, of course, you can drag back and forth to put that canvas into different states and all the other stuff I was talking about. And this tool is just perfect for it. Yes. Okay. So again, this is a very different take on state management. I'm used to this very sequential thing where you kind of like write out a namespace of logic and state, which still makes sense to me. But it's more difficult to add features to that. The more you put into a concept, the more difficult it is to change that concept and add new stuff to that concept. But if the fundamental building block is like an actor, you're forced to create these tiny things. And they can handle everything. They can handle things like, okay, you want some polling logic. You could go and grab an actor and then just put that actor into your app, like from an npm install, and then you listen to some state transition on one of your app actors, and then you trigger this polling actor, for example, and it would automatically stop when it transitions out and all this stuff. And things like selectors, for example, memoized selectors, you could do that as well. It would just be a state machine where you have cached, not cached, and it has internal state, and it listens to whatever other actors who are responsible for producing values, and then whenever one of those change, the memoized actor updates and moves between like cached and not cached, and like it's pretty trivial stuff. Yeah. Okay, I'm about to lose my voice here. Thanks for listening. I hope it made sense and was some kind of inspiration or created some questions or made you think about this concept or whatever. And have a great week, and I'll let you know if I find time to continue working on this and I have something more to show. Okay, bye-bye.